Hello everybody, a very good evening. Today we are again continuing with ammonia, but before continuing, let's have a quick revision. So ammonia, I want the students who are watching it on YouTube to just go and watch my previous video for a revision. Thank you, teacher. So students, today's session we'll be talking about the industrial or the large scale or manufacturing of NH3. Okay, it's called a large scale or manufacturing because we are producing it on a large scale. In the laboratory, we get only a small amount of NH3, but in the factories, we use this industrial method. And this method, which we are going to study today, is known as the Haber's process. It's named after the scientist who discovered this. Okay, so Haber was the scientist who discovered this process. So let's now study. Let's now first look at the setup. What kind of setup we are having here? Let's now peep into that and then we'll start. Okay, so let's see the setup now. So here we are having some two pipes are there, as you all can see, and they are meeting at one place. Okay, then we have a box, a chamber here. Okay, I'll be naming everything, you just draw along with me. Okay, yes, we are having Haber's process, we have to do that. Okay, just let me know if it is not there. Okay, then see, it leads us into this. Please keep drawing along with me. We come to this big chamber again. Okay, as you all can see. Yes, now from here the pipe continues. Okay, this is the setup. Now see, this pipe is this one which is coming from the side, gets connected here. The ones who are leaving, not at all patient. Those who don't have patience cannot get anything, because if you're waiting for some big opportunity, then you have to wait for it. Make along with me, otherwise you will get bored. Okay, now see, here we are having some catalyst. I'll name the catalyst afterwards. Okay, so this is the whole setup which we are having, and this comes down like this. Okay, so let's now see what is the whole process all about. Okay, so from these two pipes which you have seen upwards, we are letting in two gases inside. Okay, we are letting in, how many gases are there in NH3? Nitrogen is there and hydrogen is there, isn't it? Yes or no? And what is the ratio of them?
Yes.
What is the ratio? N is 1 and H is 3. So 1:3 is the ratio, isn't it? So
1:3.
Yeah. So the same thing will be happening here also. Here also we are having the same thing. Here we'll have hydrogen. Okay. Hydrogen. And we'll let it in. And this is how much? This is 3 volumes of hydrogen. Okay. And here we are letting in nitrogen. And how much nitrogen it is? 1 volume. What is the ratio? 1:3. Okay, then here the thing which is known as the compressor. Chamber is known as the compressor. I'll be telling about the process in recirculation pipe. This is the recirculation pipe. Okay, next we have some catalyst over here. I've told you. What is that catalyst? Catalyst. Which catalyst is there? It's iron. Okay, and the temperature here is 500 degrees Celsius. Okay, what's the catalyst? Let's write it here. The catalyst is iron, and there is also a promoter. Okay, and promoter. What is the promoter used here? Tell me.
Molybdenum.
Yes, it's molybdenum.
Molybdenum.
Okay. Next. Yes, yes, yes. Molybdenum. Okay. Now see, 250 atm is the pressure which is being used here. You have to just remember these things. And next, we'll have one thing I missed. We are having one more chamber here, like this. Okay. And this chamber is known as the cooling chamber. What is it known as? Cooling chamber. I hope that everybody is drawing along with me. Next, we have this cooling liquid going on inside from here. Okay, so this is what this is: cooling liquid in, and from here we are having what? Cooling liquid out. Okay, then from here we finally get what? Our desired thing. We are getting what? Liquid NH3, that is liquid ammonia. Okay, so here we are getting liquid ammonia. I hope that everybody is clear with the diagram. Now let's see the process. So this is what this is: liquid ammonia. Okay, now, and here is what is going on here. The uncombined gas is going, combined gas. Okay, this is the uncombined gas which is going out. Okay, now see, let's look at what is going on in it in the video.
But
Okay, so what happens is, can you see the, yes, what are you asking? So as you all can see, nitrogen and hydrogen coming in the ratio of 1:3, and they are straight away going. There's a compressor which makes it in a very high speed. They are coming in and they are getting a very large surface area, and then they are getting in a very narrow pipe, as you all can see, that is known as the recirculation pipe, right? Yes, so that there's a very high pressure, and then they are going into this catalytic chamber in which the catalyst iron is present in very fine it is very fine iron which is present inside, and there is molybdenum which is present inside as a promoter. Now what is promoter is the thing that increases the efficiency of a catalyst, and catalyst is what it speeds down or speeds up the reaction, but itself doesn't take part in the reaction. Okay, so molybdenum which is there, and now the temperature which is there inside this catalytic chamber is 500 degrees Celsius. Okay, now this mixture of ammonia formed along with residual nitrogen and hydrogen exchanges with their heat with the incoming unreacted nitrogen and hydrogen. So what is happening inside this mixture of ammonia formed along with residual? See here, the ammonia is being formed. Now see what's happening. The hot mixture of outgoing gases contains nearly 50%, 15% of ammonia. The mixture is passed through the cooling pipe, the condenser. Okay, as you all can see, there's a condenser, there's a big chamber which helps the high pressure which is being formed to cool down. Now the ammonia liquefies first, whereas nitrogen and hydrogen do not liquefy easily because they are uncombined. Okay, they are not the uncombined ones which have not formed ammonia. The nitrogen and the hydrogen gases, they are not combined, so they will not cool, they will not liquefy. It's very obvious. Now the uncombined one, they go back to the recirculation pipe, and then the process again continues. As you can see here, what's happening basically, I'll show you again. Yeah, so see here it comes. Here what happens, the formation of NH3 happens, but some amount of NH and some amount of nitrogen and hydrogen do not form ammonia. They are uncombined, and they again pass through this uncombined pipe. Can you see where I'm drawing the arrow? So they are going back again, and they go back to the recirculation pipe, and again this cycle continues. And comes in the examination. The thing which is important now I'm going to tell you all. So the most important thing which you have to know about the Haber's process is not this diagram, because it is rarely asked. We actually have to know about all the procedure that is happening. They've mentioned strictly in the syllabus that we just have to know about the reaction, the conditions, and the procedure. So let's start. So we'll start with the reactions. What are the reactions that are happening? So let me just, yeah. So let's start. So as you all can see, the reaction is what here we can see that N2, okay, plus H2 is coming how in gaseous state in the ratio 1:3. Okay, now in this
Your voice isn't clear.
okay, now next, okay, yeah, now it must be clear. So the conditions which are required here are, okay, so what are the conditions that are required? The conditions are that we want N2 and H2 in the ratio 1:3 by volume. The temperature should be how much? I've told you
800 degrees
temperature
Celsius.
should be between 450 to 500 degrees Celsius. Okay, the pressure should be
250 to 130.
200 atm. Haven't you studied the diagram properly? Or 250 atm.
I think I'm mixing up something.
Okay, next, the catalyst that we are using is what we are using finely divided iron, okay, to increase the surface area, which leads to increase in the efficiency of the catalyst. Okay, then we have a promoter also. What is the promoter that we need? Molybdenum or MO. Okay, next, if you want to just summarize this, we have a flowchart in the book. You can just make it here as well. So what is there? We are having these two gases coming. First of all, they come into the compressor chamber, then they comes into the catalytic chamber in which the catalyst is present, and then they come into the condenser where they get condenses and liquefies, and then we get liquid ammonia here. Okay, and if it is not condensed, then what happens? It goes again to the compressor chamber. Okay, I don't think so that we have to write all the things again. I'll just write that here N is coming and here H is coming in the ratio. What is the ratio? The ratio is 1:3. They are going in, and then what happens here? What is the pressure? The pressure here is greater than 200 atm. Then here is the catalytic chamber. Here what is there? Here Fe and MO is there. What else do we need here? Need a temperature of 450 degree to 500 degrees Celsius, and the pressure should be 280. Okay, next, here we'll get the liquid ammonia. When it will get condensed inside this, if it is not condensed, it will again go back to the compressor chamber. I hope that this thing has created a blueprint in your mind, right? Now next, we move on to, let's see the overall reaction of this. Let's look at the overall reaction. What happens? One more thing to be mentioned here, that This N2 is adding up with three molecules. Yes, doesn't break now. Okay, so we were looking at this overall reaction. So this N2 plus 3H2, that is in the ratio of 1:3. It combines and brings and gives us NH3 plus a large amount of heat is released. Okay, and then what all we have here, we have to mention it here. We are having what? We are having iron and molybdenum. Okay, we are having the temperature of 450 to 500 degrees Celsius. Yes, and we are having temperature of 200, pressure of 200 atm, that is atmospheric pressure. Okay, next. Yes. So now let's see another method of preparation. We'll be looking at the method in which we use metal nitrides. Nitrides means N2. Okay, so we'll use magnesium nitride here. Okay, so ammonia can be used by the can be also be prepared by the action of warm water on any metal nitride, such as, let's take for instance magnesium or aluminum as the metal. So let's take magnesium and aluminum nitride. Okay, so ammonia can be prepared by direct action of warm water. Okay, please keep that in mind that we are having what? A warm water. So I'll just make the apparatus, how does it looks, and then you will be very clear with it. Okay, so we are having the apparatus in which we are having a thistle funnel in which we are having warm water. As you all can see, this is a thistle funnel which goes inside a round bottom flask. Okay, and this flask is having the metal nitride. Okay, so this is the flask in which we are having what? We are having the metal nitride. Let's take MgN. Just give me a minute. Yeah, so we are having M2 Mg3 and 2. Yes, it's balanced. So, and ALN. We can have any of the two. It's not compulsory you have both of them. You have to have only one out of the two. Okay. Next, we are having warm water inside it. So we are having what? We are having here warm water. Okay. Okay, so what is the reaction? Let's look at the reaction now. And what happens here? Here we have another pipe which goes into for collection. Okay, rest is the same as we have done in the laboratory. We have actually not done the laboratory method. Next else remains the same. Okay, the thing remains the same. Here we are having for collection of it. We just move it on to a next. Vessel. I think I need to draw the whole thing now. Okay, let's now see what's there. And inside here is some agents. I'll let you know what agents are there. They are the drying agent. You must be knowing of the names of some drying agents from before only. And these are held with these stands here. Okay, I hope that is clear. It's clear. The diagram is clear. So let's now see what is the reaction that is happening. So see, here let's first look at the reactants and the products what we are getting. Okay, first let's look at the reactants. Reactants, what are the reactants? We are having metal nitrides like magnesium nitride plus warm water. Then we have the reaction. What is the reaction? Let's look at the reaction. The reaction is like this nitride of magnesium combines with water to give us magnesium hydroxide, MgOH whole twice, plus we get our desired gas, that is ammonia. Okay, I hope that this is clear. Now if we take aluminum for instance, then what we'll be getting if I have aluminum Al SH2, everything will be the same.
Aluminum
Just
hydroxide plus
the thing that
Ammonium hydroxide.
very good. Ammonia, yes. And the drying agent